Imagine your outstretched arms representing the entire history of our world, spanning 4.5 billion years. From your right middle finger to your left, every inch tells a story of survival and transformation. Your right arm begins as a hellscape of molten lava, a testament to the planet's violent infancy. To understand how we got here, we must travel back to the very first sparks of light. Around 4.5 billion years ago, the lights of our solar system finally went on. Our sun began its life, undergoing the intense pressure of nuclear fusion for the first time. Surrounding this new star was a chaotic, gigantic cloud of dust and gas. Within that debris, a big clump of rock and metal began to take shape. Gravity acted as the master architect, drawing this material together into a planetesimal. Think of it as a planet that wasn't quite fully baked yet. Soon, the crushing force of gravity pulled the mass into a glowing sphere of molten lava. As the planet swirled, heavy elements like iron and gold began to sink toward the center. These heavy metals formed the Earth's inner core, the heart of our world. This core was essential because it generated the planet's first magnetic field. This invisible shield would eventually protect future life from the sun's harsh solar winds. But the magnetic field could not shield the young Earth from the giants lurking in the dark. A Mars-sized planet named Theia was on a collision course with our future home. Theia plowed into the Earth with unimaginable, world-shattering force. The impact was powerful enough to knock our planet completely off its axis. A moon-sized ball of magma was blasted outward into a chaotic orbit. This debris eventually coalesced to create the companion we know as our moon. This was a time of pure, unadulterated violence for the early solar system. Asteroids and comets smashed into the cooling planet on a regular basis. But these space rocks didn't just bring destruction, they delivered something precious. Inside those icy visitors was the water that would one day fill our oceans. Slowly, the surface of the Earth began to cool and harden into a rocky crust. This new crust was much like the hard surface of a freshly baked loaf of sourdough bread. Eventually, the surface temperature dropped below the boiling point of water. For the first time in history, water condensed to create the very first oceans. And it was in these dark, deep waters that something wild was about to happen. About 4 billion years ago, deep underwater, the conditions for life began to stir. Hydrothermal vents acted as chemical factories, rich with energy and rare minerals. These vents pumped out the 6 crucial elements necessary for all life on Earth. Carbon, hydrogen, nitrogen, oxygen, sulfur, and phosphorus swirled in the darkness. In these unique settings, those elements reacted with toxic ingredients like hydrogen cyanide. Together, they began to create the precursors to amino acids, lipids, and even RNA. The beginning of life wasn't a single cosmic spark, but a series of relentless chemical reactions. These reactions created a complicated biomolecule that could do something miraculous: make more of itself. Once that chemistry started, 4 billion years ago, it became an unstoppable force of nature. But while life stirred in the depths, the planet's interior was brewing a much hotter, deadlier secret. Far above, the first land masses were about to break through the surface of a world that was still very much on fire. The roaring fires of the primordial landscape slowly began to dim as the planet's surface heat radiated into the void of space. A thin, fragile crust of solid rock started to form across the molten globe like the surface of cooling sourdough bread. High above this hardening shell, the atmosphere was thick with toxic gases and heavy clouds of water vapor. Suddenly, the silence of the cooling world was shattered by a relentless bombardment of icy visitors from the outer solar system. Asteroids and comets slammed into the rocky surface, releasing massive payloads of frozen water upon impact. As the surface temperature finally dipped below the boiling point, the atmosphere could no longer hold its heavy moisture. For the first time in history, rain began to fall in a torrential downpour that would last for thousands of years. This cosmic deluge filled the low-lying basins of the crust, giving birth to the very first oceans. Deep beneath these turbulent waves, the weight of the New World's oceans pressed down onto the thin crust. Far below the surface, the planet's internal heat forced its way out through massive cracks in the seafloor. Towering chimneys of mineral-rich rock rose from the darkness, spewing plumes of superheated black smoke. These hydrothermal vents became chemical cauldrons, rich with energy, and the 6 essential building blocks of life. In this unique, high-pressure environment, complex molecules like hydrogen cyanide and hydrogen sulfide began to react. Under the intense heat and pressure, these ingredients combined to create the precursors to amino acids and lipids. The dawn of life was not a single moment of magic, but a relentless chain of complex chemical events. Around 4 billion years ago, a biomolecule finally emerged with the extraordinary ability to replicate itself. Once this self-sustaining chemistry began, the pulse of life on Earth became an unstoppable force. For hundreds of millions of years, these microscopic pioneers would remain hidden in the dark, churning depths. Above them, the Earth's interior remained a churning furnace of incredible heat and pressure. This internal fire fueled the growth of ancient volcanic islands that poked their heads above the waves. Deep within these volcanoes, the planet was forging massive deposits of gold and silver in its veins. This second wave of metals arrived via a fresh delivery of asteroids that restocked the cooling crust. As the planet aged, the simple chemical replicators began to evolve into more robust single-celled organisms. Meet Luca, the last universal common ancestor of every living thing that would ever exist. Luca was the great-grandparent of every cactus, every shark, and every human to come. But while life was taking its first steps, the world above was still a landscape of alien chemistry. The atmosphere was choked with methane, creating a thick greenhouse blanket that kept the world toasty. Under this orange sky, a new kind of organism began to emerge in the shallow coastal waters. These were the cyanobacteria, microscopic masters of a revolutionary new biological technology. They had learned how to harvest energy directly from the sun through the process of photosynthesis. But this success came with a hidden cost that would eventually change the world forever. As a byproduct of their growth, the cyanobacteria were releasing a potent and deadly gas into the environment. That gas was oxygen, a substance that was toxic to almost every other form of life on the planet. For billions of years, these tiny microbes pumped out more and more of this reactive gas. The oxygen began to react with the methane in the atmosphere, stripping away the planet's heat-trapping blanket. Without its greenhouse gases, the temperature on Earth began to plummet toward a terrifying extreme. The very life that had flourished was now inadvertently steering the planet toward its first global catastrophe. The Great Oxidation Event was not just a change in air, it was a biological weapon that threatened to end the story of life. As the world began to freeze over, the survivors were forced to adapt or be erased from history forever. But even as the ice closed in, Something far more massive was hurtling through the void toward the shivering planet. The massive asteroid that loomed in the darkness of space finally veered away, leaving Earth to face a far more insidious internal transformation. Below the surface of the emerald-tinted oceans, a new kind of microscopic architect began to multiply in staggering numbers. These were the cyanobacteria, tiny organisms that had discovered the secret of harvesting energy directly from the sun. Through the process of photosynthesis, they began to consume carbon dioxide and release a volatile byproduct, oxygen. At first, the iron in the oceans absorbed this new gas, rusting and falling to the seafloor in great red layers. But soon, the minerals could hold no more, and the oxygen began to leak out of the sea and into the sky. For the dominant life forms of the era, this new gas was not a gift of life, but a deadly, corrosive poison. The Great Oxidation Event had begun, marking the start of the first mass extinction in the history of the world. Billions of anaerobic organisms perished as the very air they touched tore their simple structures apart. As the oxygen levels climbed, the methane, a powerful greenhouse gas, began to vanish from the atmosphere. Without the methane blanket to trap the sun's warmth, the global temperature plummeted with terrifying speed. Ice began to form at the poles, creeping steadily toward the equator like a white shroud.
Within a few million years, the entire planet was encased in a layer of ice several kilometers thick.
The vibrant, volcanic world was silenced, replaced by a frozen desert where life clung to a few remaining pockets of warmth. Deep beneath the ice, near the hydrothermal vents that had birthed them, a few hardy survivors endured the long winter. These survivors began to adapt to the presence of oxygen, learning to use its high-energy potential to their advantage. The catastrophe of the Great Oxidation had paved the way for more complex, high-energy biological processes. While life evolved in the depths, the surface remained a static, frozen wasteland for hundreds of millions of years. Volcanic activity slowly continued beneath the ice, building up pressure that would one day break the planet's frozen grip. Huge amounts of carbon dioxide were pumped into the atmosphere, trapped beneath the ice and slowly thickening the air. The greenhouse effect returned with a vengeance, and the ice began to fracture and melt in a global thaw. Torrents of meltwater flooded into the basins, carrying minerals and nutrients that had been locked away for eons. Life exploded back into the sunlit shallows, fueled by a newly oxygenated world that was ripe for change. Around 2 billion years ago, the land itself began to stir as tectonic plates crashed together. This collision formed the first true supercontinent, a colossal landmass known as Columbia. Columbia was a barren, rocky expanse devoid of any green life and battered by relentless radiation. Without an ozone layer, the sun's ultraviolet rays scorched the surface, making life on land impossible. However, in the protective depths of the sea, life was undergoing a radical upgrade. Simple cells began to merge, with larger ones swallowing smaller ones to create symbiotic partnerships. These were the first eukaryotes, the ancestors of every complex plant and animal that would ever exist. As Columbia began to drift and fragment, the oceans between the continents grew wide and deep. The planet was now a world of blue and brown, a marble finally stabilizing after billions of years of chaos. Yet, the cycle of ice and fire was far from over, as the continents continued their slow-motion dance. Around 1 billion years ago, the land assembled once more into a new giant, the supercontinent Rodinia. Rodinia's position blocked the warm currents of the world, setting the stage for another catastrophic freeze. The second Snowball Earth was arriving, threatening to erase everything life had worked so hard to build. Oxygen was now abundant, but the world was becoming a prison of ice once again. Many branches of the Tree of Life were cut short, unable to survive the brutal cold and lack of sunlight. But in the darkest, deepest trenches, a new kind of multicellular cooperation was being whispered among the cells. As the ice sheets groaned and the supercontinent Rodinia began to tear itself apart, something unprecedented was about to crawl out of the shadows. The fading warmth of the methane atmosphere left the world vulnerable to a creeping, crystalline chill. Without its greenhouse blanket, the planet's temperature plummeted faster than the primitive life could adapt. Glaciers began to grind their way from the poles, claiming the vast, empty oceans in a relentless march of white. Beneath the thickening ice, the hardy descendants of the Great Oxidation Event struggled to find the sun's fading energy. This was the era of Snowball Earth, a planetary tomb of frost that lasted for millions of silent years. Deep in the void of the solar system, a new threat moved toward the frozen world with terrifying speed. A rock 20 kilometers wide, double the size of the one that would later kill the dinosaurs, pierced the thin atmosphere. It slammed into what is now South Africa with the force of 1 billion atomic bombs. The very crust of the Earth buckled and folded back on itself under the sheer pressure of the Vredefort impact. This violent upheaval buried vast gold fields deep underground, shielding them for eons to come. Massive plumes of dust and carbon dioxide erupted into the air, finally beginning to trap the sun's heat once more. The long winter began to break as the ice sheets retreated, revealing a world reshaped by fire and frost. Tectonic plates, driven by the churning heart of the planet, began to huddle together in the center of the world. This was the birth of Columbia, the first true supercontinent, a colossal island stretching across the equator. Stretching nearly 13,000 kilometers, Columbia was a barren wilderness of rock and dust. The air was still thin and lacked a protective ozone layer, leaving the land scorched by lethal radiation. While the land remained a dead zone, the shallow seas surrounding Columbia became a laboratory for evolution. In the warm shallows, different types of single-celled organisms began to interact in ways they never had before. One large cell made a fateful choice, engulfing a smaller, energy-producing bacterium without digesting it. This bizarre partnership created the first mitochondria, the internal engines that would power all complex life. From this union emerged the eukaryotes, cells with organized rooms and specialized tools for survival. These were the distant, microscopic blueprints for every complex plant and animal that would ever exist. For hundreds of millions of years, these tiny pioneers perfected the art of being alive in the shadow of the supercontinent. Columbia stood as a monolithic guardian of the world, resisting the tides and winds for 1 billion years. But even the greatest land masses are not eternal, and the heat trapped beneath the crust began to push back. Huge rifts began to tear through the heart of Columbia, splitting the supercontinent into smaller, drifting islands. The pieces scattered across the globe, rearranging the world's oceans and currents in a slow-motion dance. 1 billion years ago, the land masses found a new configuration, merging once more into the supercontinent Rodinia. Rodinia was a giant wall of rock that blocked the warm currents of the sea from reaching the poles. Once again, the world began to cool as the lack of circulation sent the planet back toward the edge of ice. As Rodinia itself started to fracture 750 million years ago. A new geological crisis emerged. Torrential rains began to pour down on the newly exposed rocks, washing away the carbon dioxide from the air. The loss of these gases triggered a second, even more terrifying snowball Earth phase. For millions of years, the world was a silent, frozen wasteland where life seemed to have finally met its end. Yet, beneath the miles of ice, the volcanic vents continued to pump out minerals and warmth. In these hidden pockets, the eukaryotes didn't just survive, they began to cooperate. Simple microbes were evolving into the first multicellular structures, like sponges and seaweeds. The ice was finally starting to melt, and the chemical composition of the oceans was shifting towards something explosive. Calcium levels began to skyrocket, providing the raw materials for a biological revolution. As the ice sheets groaned and the supercontinent Rodinia began to tear itself apart, something unprecedented was about to crawl out of the shadows. The frozen grip of the second snowball Earth finally began to loosen as volcanic fires stirred beneath the ice. Deep within the crust, the supercontinent Rodinia groaned under the pressure of rising mantle plumes. Slowly but inevitably, the giant landmass began to tear itself apart, creating vast new rift valleys. These widening gaps allowed the ocean to rush in, flooding the interiors of the once dry continents. In these warm, sunlit shallows, the simple eukaryotic cells faced a new environmental challenge. Instead of remaining solitary, these complex cells began to cling together for survival. This was the birth of multicellularity, where specialized cells worked in harmony for the first time. As oxygen levels surged, life was no longer content to simply drift or sit on the seafloor. We have now reached the left wrist of our human timeline, marking the start of the Cambrian explosion. Within the span of a few million years, the variety of life on Earth increased by orders of magnitude. A sudden spike in ocean calcium allowed organisms to build the very first hard shells. This development triggered a desperate evolutionary arms race between predators and prey. If one creature developed armor, the hunter responded by evolving powerful, crushing jaws. Spikes and defensive plates became the latest fashion in the brutal theater of the sea. Among these oddities appeared a small, needle-like creature called Pikaia. This unassuming worm possessed a primitive rod of cartilage, the precursor to our own spine. From this tiny ancestor, the entire lineage of backboned animals, including us, would eventually spring. As life flourished in the water, the continents continued their slow dance across the globe. The land remained a harsh and desolate place, scorched by unfiltered ultraviolet radiation. But deep beneath the waves, the atmosphere was slowly being rewritten once again. The formation of the new supercontinent Gondwana was about to alter the planet's thermostat. As Gondwana drifted toward the South Pole, it began to accumulate massive amounts of ice. These growing glaciers locked away so much water that the global sea levels began to plummet. The vibrant shallow reefs, the cradle of Cambrian life, were suddenly exposed to the air. This environmental collapse triggered the Ordovician extinction, wiping out 85% of all species. Yet in the deep refuges, the survivors began to rebuild and reinvent themselves. New forms of life emerged, including the first fish with primitive biting jaws. The ocean floor was soon covered in a carpet of strange, primitive plants. Some of these plants began to creep toward the edges of the continents, testing the dry air. This was the first time the brown and gray land began to show a hint of emerald green. Beneath the surface, the evolutionary engine was revving up for its greatest feat yet. Powerful armored predators now patrolled the oceans, making the open water a dangerous place. To escape these monsters, some creatures sought safety in the shallow, muddy estuaries. Tiktaalik, with its unique limb-like fins and a neck, began to peek its head above the water. It breathed in the rich oxygen of the atmosphere, a feat that would change history forever. The land was no longer a forbidden zone, but a vast, empty frontier waiting to be settled. These early pioneers were the first to walk, pave the way for the giants that followed. Above them, the first true forests were beginning to rise, their roots anchoring the soil. But the earth is a restless host, and the peace of the new forests was only temporary. As the first shadows of predatory insects darted through the leaves, a much larger transformation was looming on the horizon. The humid air of the Devonian period hung thick over the vast, swampy estuaries of a changing world. Beneath the murky surface of the shallows, a creature with pectoral fins like sturdy paddles stirred in the silt. This was Tiktaalik, a biological bridge between the depth of the ocean and the promise of the shore. With a powerful thrust of its muscular limbs, the fish-like pioneer hauled its head into the oxygen-rich air. It gulped the atmosphere through primitive lungs, claiming a territory that no vertebrate had ever conquered. Over millions of years, these awkward lunges evolved into the confident strides of the first true tetrapods. While life claimed the land, the very foundations of the earth were drifting toward a massive collision. The ancient oceans of Iapetus and Rake began to close as the continents moved with unstoppable momentum. Colossal mountain ranges were thrust upward as Gondwana and Euramerica finally collided. From this geological forge, the supercontinent of Pangaea was born, a single island in a world-spanning sea. Giant dragonflies with wingspans of 2 feet darted through the oxygen-rich forests of the Carboniferous. Massive millipedes, long as a man, scurried across the forest floor in search of decaying plant life. High oxygen levels allowed these invertebrates to reach terrifying proportions in the absence of large predators. As the trees died, they sank into the oxygen-poor mud, forming vast layers of carbonized peat. These ancient graveyards would eventually become the coal seams that power the modern human world. But the wet, swampy world was soon to face a drying trend as Pangaea moved into a new climate era. A new group of animals appeared, possessing the revolutionary ability to lay eggs with hard shells. These amniotes no longer needed to return to the water to breed, untethering life from the shoreline. Predators began to diversify with sharp teeth and agile bodies designed for life on the open plains. Yet the interior of the supercontinent became a vast, inhospitable desert where water was a rare treasure. Life was pushed to its limits as temperatures soared and resources dwindled. Beneath the surface, deep within the Siberian crust, a terrifying geological pressure was building. The Earth's mantle began to rupture, preparing to unleash a cataclysm that would dwarf all previous extinctions. For thousands of years, the Siberian traps erupted, flooding the world with basaltic lava and toxic gases. The atmosphere turned acidic, and the oceans began to suffocate as the oxygen was stripped away. More than 90% of all species vanished in what would be known as the Great Dying. Silence descended upon Pangaea, broken only by the whistling of ash-laden winds. But in the shadows of the ruins, a few hardy survivors clung to existence in the burrows and cracks of the earth. These survivors would become the architects of a new world, a world of scales and thunder. As the Permian gave way to the Triassic, the supercontinent began to heal, though its scars were deep. Evolution took a radical turn, experimenting with new body plans and specialized niches. In the rivers, giant amphibians vied for dominance with the ancestors of modern crocodiles. But a small, bipedal predator was emerging from the undergrowth, built for speed and endurance. The stage was being set for the greatest dynasty in Earth's history, the dinosaurs. These creatures possessed a unique hip structure that allowed them to walk upright, saving immense energy. They began to fill every corner of Pangaea from the polar forests to the equatorial plains. However, Pangaea itself was beginning to groan under the strain of internal heat. The supercontinent was destined to tear itself apart, creating the Atlantic Ocean in its wake. As the land fractured, the climate shifted once more, paving the way for the giants of the Jurassic. But as the first massive sauropods shook the Earth with their weight, a new and unexpected terror was stirring in the deep oceans. While the oceans remained a realm of hidden terrors, the land began to crack under the strain of shifting tectonic plates. Around 175 million years ago, the supercontinent of Pangaea initiated its slow and messy breakup. As the Atlantic Ocean unzipped between the drifting continents, the global climate underwent a radical transformation. The once dry and scorching interior of the supercontinent was reborn as a lush, tropical paradise. This new world became the ultimate all-you-can-eat buffet for the true stars of the prehistoric show. With an abundance of plants to consume, the herbivorous dinosaurs began a period of massive evolutionary growth. Long-necked sauropods soon evolved into creatures as tall as 4-story buildings. These massive animal skyscrapers were so heavy that the ground literally shook with every thunderous step. For millions of years, these giants dominated a landscape that was finally beginning to look like our modern home. By the time the Jurassic transitioned into the Cretaceous, the planet was undergoing its most iconic makeover. The steaming hot climate of this era meant there was absolutely zero polar ice on the planet. Because of the heat, sea levels rose to nearly 200 meters higher than they are today. Earth became a beautiful world of giant islands and vast, lush tropical archipelagos. This was the golden age of the Cretaceous, where apex predators like the Tyrannosaurus rex ruled supreme. Formidable herbivores like the Triceratops lived in a delicate balance with these fierce carnivores. But as these majestic reptiles flourished, a silent clock was ticking toward the most famous bad day in history. Just 66 million years ago, a 10-kilometer-wide asteroid was hurtling toward its target on Earth. It was lining up its sights precisely with the shallow waters of the Yucatan Peninsula. In a literal flash, 160 million years of reptilian dominance ended in a catastrophic boom. The impact released the energy of billions of atomic bombs, vaporizing everything near the site. Huge tsunamis, hundreds of meters high, raced across the oceans to drown the distant shores. Red-hot debris rained back down from the sky, igniting global wildfires that consumed the continents. The aftermath of this cosmic impactor wiped out 75% of every species on the planet. A thick shroud of dust and sulfur blocked the sun, triggering a long and deadly nuclear winter. No land animal larger than 25 kilograms could find enough food to survive the collapse. But amidst the ruin and the ash, a tiny group of survivors managed to endure the catastrophe. Our shrew-like mammal ancestors stayed hidden, feeding on insects and roots beneath the frozen earth. These resilient creatures were the humble torchbearers for the future of all complex life. With the giant dinosaurs gone, a massive power vacuum opened across the entire world. Mammals quickly took off in all directions, filling the ecological niches left behind by their former overlords. Within 30 million years, those crafty little creatures evolved into an incredible variety of forms. Some mammals returned to the sea, eventually becoming the massive whales we know today. Others stayed on land, growing larger and more specialized as the world continued to change. The continents continued their slow drift, moving closer to the positions they occupy on our modern maps. In the forests of Africa, a specific group of mammals began to develop unique social structures. These primates were developing the intelligence and dexterity that would one day change the planet forever. The stage was set for the final act of this 4.5 billion year journey. But even as life recovered, the climate began to cool once again, bringing a new challenge for the survivors. In the shadows of the receding forests, a new kind of creature was about to stand on its own 2 feet. Yet, just as they began to master their environment, a sudden and terrifying shift in the Earth's orbit threatened to plunge them into total darkness. The world fell silent as the dust from the Great Impact settled over the scorched remains of the Dinosaur Empire. Beneath the surface, in the cool darkness of the soil, a tiny heart continued to beat with stubborn persistence. These small, shrew-like ancestors were the unlikely heirs to a planet that had just been cleared of its giants. With the dinosaurs gone, the ecological niches they once held stood empty, waiting for a new champion. Within 30 million years, these resilient mammals began to diversify into a dizzying array of forms. Some returned to the sea, evolving into the massive whales that would eventually rule the deep blue oceans. Others remained on land, honing their intelligence and social bonds as the continents drifted into their modern shapes. As we reached the final knuckle of our journey, a new kind of creature began to emerge in the African savanna. Sahelanthropus was among the first to rise from all fours, taking hesitant steps on 2 legs. This change in posture granted them a new perspective, allowing them to see over the grass and spot both danger and opportunity. Millions of years passed in a flash, and hominids like Lucy began to walk upright with growing confidence. The discovery of fire 800,000 years ago changed the course of history forever. Fire provided warmth, protection from the night, and a way to cook food that fueled their expanding brains. 40,000 years ago, Homo sapiens emerged as the sole survivors of the human lineage, masters of their world. They began to leave their mark, painting stories on cave walls and crafting tools of bone and stone. At the very tip of the fingernail, just 5,500 years ago, the first great civilizations arose. Humans began to write, record their history, and ask the profound questions that still drive us today. We are the culmination of 4.5 billion years of chaos, collision, and survival. Every breath we take is a gift from the cyanobacteria that terraformed our atmosphere eons ago. Every drop of water in our bodies was delivered by asteroids that smashed into a cooling Earth. The gold in our rings and the iron in our blood are the remnants of cosmic collisions and volcanic fury. From the tip of our right finger to the tip of our left, Earth's history is a story of incredible scale. We occupy only the smallest sliver of time, a mere speck on the grand timeline of our planet. Our journey began with a ball of molten rock and a violent impact that gave us our moon. It continued through snowball eras and supercontinents that broke apart to shape the world we know. We saw the rise and fall of giants, from armored fish to the massive dinosaurs that ruled for millions of years. Through every mass extinction, life found a way to adapt, evolve, and thrive once more. And now we stand as the narrators of this epic tale, the only species capable of understanding its own origins. Our story is far from over as we continue to explore the mysteries of our planet and the stars beyond. Every person, every city, and every moment of history is contained within that tiny fingernail of time. We are the guardians of a fragile blue marble that has survived the most violent of trials. Our existence is a testament to the power of evolution and the enduring spirit of life. As we look back across the 4.5 billion years, we see not just the past, but the foundation of our future. The universe is vast and ancient, yet it has produced something as complex and beautiful as us. We must honor the journey that brought us here by protecting the world that sustains us. Every discovery we make is a new chapter in the ongoing saga of the Earth. From the first chemical reactions to the launch of spacecraft, we have come so incredibly far. Let us never forget the giants upon whose shoulders we stand, from the microscopic to the massive. Our story is written in the rocks beneath our feet and the stars above our heads. This is our home, our legacy, and our grand journey through the deep time of the blue marble.